All right. So we're taking a look at this question here where we're asked to analyze the motion of two cars. Car A, moving in a straight line at constant speed, 17.5 meters per second, is initially 190 meters behind car B, moving in the same straight line at a constant speed of 12.5 meters per second. How far must car A travel from this initial position before it catches up with car B? So I'm going to write down three things that we know. We know the initial velocity of car A. We know the initial velocity of car B. And I'm going to write down that the distance between them, the gap between them, I'm just going to call delta x. Right? So in this specific question, car A's velocity is 17.5 meters per second. Car B's initial velocity is 12.5 meters per second. And the initial distance between them is 190 meters. Now, what does it mean for car A to catch up with car B? I think one way to better understand that is to draw a graph of the position versus time for these two cars. So for car A, which I'll draw in blue, right, we're going to imagine it starts at the origin, okay, and it's going to move at some velocity, right, where that velocity is going to be the slope of this graph, right? And car B is going to start with some amount of head start, right? This distance here of delta x, and it's moving at this different velocity, which if you think about it, the only way car A could catch up to car B is if car A is traveling faster. Now, what does that mean for this graph here? Well, it means that car B is traveling slower, and so its slope must be less steep, right? Otherwise, let's imagine that car B was going the same speed or faster, then these two cars would never catch up. And by catch up, we're specifically looking at the spot where they have the same x at the exact same time. That's what it would mean to catch up. Not that they have the same x or that they have the same time, but they both have to match up. And so what we're trying to do is solve the simultaneous equations, right? The intersection of these two lines. So let me go ahead and write down these equations again. So the position of car A is going to be the velocity of car A multiplied by the time. And the position of car B is going to be the velocity of car B times the time with that extra piece of its head start. Okay? And what we are trying to solve for is the value of x. And so we have a couple of different strategies here. And what I'll do is let's take this, we'll take the first equation and we'll solve it for time and plug it into the second equation. So the first equation solved for time, t equals x divided by VA. Okay? And then I substitute this in for this value of time. And so now I get x equals VB times x all over VA plus delta x. Okay. Then I will move this to the other side. And I'm just going to switch to black now, x minus, I'm just going to slightly rewrite this, x times VB over VA equals delta x. Okay, and again, I'm trying to solve for x by itself. These three things are my three given pieces of information. I'll pull out an x, I'll factor out an x. So x1 minus VB over VA equals delta x. And I'm just going to take a quick second and I'm going to change this. I'm going to add these together. So 1 minus VB over VA. Well, that's the same thing as VA over VA minus VB VB over VA. I just got a common denominator, VA over VA. That's equal to 1. And now that I have the common denominator, I get VA minus VB all divided by VA. And so if I want to divide both sides by this, that's the same thing as multiplying by the reciprocal. So I'm going to get x equals delta x times, and I take the reciprocal of this, which I just flip the numerator and the denominator. And that's the reason why I wanted to add these together first, so that I wasn't dealing with dividing by this big, dividing by this whole mess here. I would much rather be able to write this as VA divided by VA minus VB. Right? And I can think of that as like one, this right here is like one unit here that I would calculate. And so I'll be able to plug in my 3 numbers and be able to get an answer. You'll notice that V divided by V, those units would cancel out, and I'll be left with my answer that is just in meters. So I recommend going through, plugging in your specific numbers, and you'll be able to get this question no problem at all.